G'day YouTube. Baubles on a lot here. Fairly well advanced in a dust accretion study on A13P7. Those of you familiar with the channel may recall seeing the dust accretion study on its predecessor. And it occurred to me that it's working at pretty good speed at the moment. Might be a good time for me to illustrate what a good job this unit does. There we can see the temperature of the wall. As we come over above 260 degrees Celsius. The reason it's colder there is because of the cold air getting sucked into the firebox. Now there's a region in there, up at the back, where it's above 270. Back wall, 45, 35. Okay. And now, start again and we'll traverse a little bit higher. Are we there? Now there we're getting the temperature of the reflective builder's foil. Now we're getting the temperature of the air coming through the disc. And then temperature drops off again. Reason it's elevated in there is because you've got your building insulation reflecting the radiant heat off the flue. Come up a bit. Temperature of the flue, 78, 80 or so. Back to 57. So what's happening is the fan is sucking the air, which is being warmed, and hot air rises, so it would otherwise be coming straight up. Well, what's happening now is it's getting sucked in by the Peltier-Powered stove fan. And at 48 or 50 inches distance, it's just got enough strength to the airflow to get the Skycraft Scout to align with the airflow. Not enough for the Wright Brothers Flyer, and not enough for the B-29 either. So tomorrow morning, I'll get to have a look at the aerofoil sections and see how much dust has stuck to which surfaces. Before starting today's run, which will be something around 10 or 12 hours, it had already done 6 hours last night, and it seemed to have a more or less equal amount of dust stuck to both front and rear surfaces, which indicates that, yeah, the thick leading edge is a mistake in this application. High lift might work well on a foot launched hang glider, but it's not much chop at all on a low speed electric air screw. Top of the heat sink, 62, 63, 64 degrees. Top of the collector, 128 degrees. 91 degrees on the bottom of the conductor, 70 degrees on the cold side. Whoops. .96. So 70 on one side, 96 on the other side. 26 degrees Celsius, and yeah, it's doing slightly less than 300 revs a minute. So it's something like 10 degrees Celsius temperature gradient across that Peltier device there in the center of it. 10 degrees equals 100 revs per minute, more or less, roughly. From 15 degrees up to about 35 degrees. It's a good ratio. The hub of the propeller stays pretty cool. Warbles on a lot to YouTube. Ciao. Hot chocolate tonight. Have a good one.